Hey everyone, this is Maths Guy Channel here, and today we're going to be differentiating exponential and trigonometric functions. A quick review for differentiation. Differentiation is a way of working out a gradient and a point for any function, any smooth and continuous function, and the other details about conditions that must be met for a function to be differentiated. I was in the previous video of reviewing differentiation. And yeah, the image on the right is from the Jacaranda I believe 6th edition of 2019-2023, starting this time. Quick review of differentiation. So if f dash of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So it's the rise over run. Instead of x of x1, y1, it's f of x plus h and f of x. And the rule is for f of x of e k of x, f dash of x is k e k of x. And this is the unique properties of the function e. And the second part is if f of x is e raised to a function, if dash of x is the derivative of the function, multiplied by e raised to the power of the function. And one of the things to clearly note is that this rule only works for base e. If you have like, I don't know, instead of e you have like 2 or something, it gets a lot harder, and in that case you'll probably be putting a calculator in anyway. So for example, we have f of x equals e of x minus 2 all squared. So what you can do is expand that out, so you can have e raised to the power 2 of x, because ex times ex. So when you're multiplying powers, so it's basically going to indices laws, e of x times e of x, you add the powers together, so you get 2 of x minus 4ex plus 4, and then you can differentiate each part. So e of 2 of x becomes 2e2 of x minus 4e of x, and then the constant is dropped. Next, we're going to go through sine, cos, and tan. So the image on the right, if you really want to work it out, you can use that to work out the point Q. That's Q because it's tangent to the quarter circle. So if f sine of x, the derivative of sine of x is cos of x. And you talk about how the turning point of a function is an x-intercept of its derivative function. That's how you get cos of x. If it's sine of k of x, then the k comes out as well, so it becomes k cos of k of x. And if it's sine of a function, then it's the derivative of the function multiplied by sine g of x. This is based on what's called the chain rule, but we have not gone through that yet. But for the time being, it's best to just remember that formula. And then cos is a very similar thing. So cos of x, its derivative is negative sine of x, and if you take the turning points of cos of x and you sketch the gradient function, the gradient function would have x intercepts where the turning point is. And if you take the gradients into account between the turning points, you can realize that cos of x, if you work out why cos of x, the derivative of cos of x is minus sine of x. And same thing with cos of k of x, it's k minus k sine kx. And same with g of x is cos of g of x is f dash x is negative g dash x cos gx. Tan is a lot trickier, because there's no really. It's also obvious if you were to draw the diagram, but if you have f of x equals tan of x, it equals 1 over cos squared x. So this is the same as cos x all squared. This is notation, which is sec squared x. You probably, in the methods course that this book is derived from, good joke. You probably won't go. This is probably the only time you'll see secant. This is usually seen. This is seen more often in higher level mathematics. But the time being to realize it's just sec squared x. Tan of k of x is k derivative of tan k of x is k sec squared k of x. And g of x, you have tan of g of x, and f dash of x is g dash of x sec squared g of x. I know that's already a lot of rules. But yeah, this is the main rules you need to remember for the trigonometric differentiation of the trigonometric and exponential functions. There are other functions like sec, cosec, and I forgot arctan, that sort of thing. But we probably will be going through these in these videos. And yeah, that'll be all.